This is not really the idea, but it's also part of it. You have to really try to, because when you start thinking about it, this is how you learn programming. You have to like break it down and do sometimes even do the wrong thing, and then just for you to have thought about all of this, you actually learn it. And yeah, and she had that own implementation, which is quite interesting. So I did solve it also myself, but um, let me see. Is my own solution. Uh, the test. Yeah. So this was my own solution here. Multiplication table. So quite interesting. The only thing I copied from Chinonso, because I saw Chinonso's old stuff. My own didn't have this block here. And I've never used printf before. So that was quite interesting to see. I just did print actually. So I even learned something from you guys. This was my original implementation. And what that does is, of course, I put some space in between, but it kind of like packs it together. I think my implementation was something like this. This was my original implementation. So this was it. But yeah, so you see 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So it's pretty much, but you see, because some numbers are um, have 2 digits, it starts like moving and pushing others. So that's where that print f comes in, which was quite interesting to see that you could do that.
Yeah, that kept me there for long.
Is that is that what? Oh, okay. All right. So let's run this again, and we see now that everything is properly aligned, because what the printf is doing is you're saying that you're taking 4 spaces and it has to fill in 4 spaces. So you see the dots here, 1, 2, 3, 4. So it takes in 4 space. The next one takes 4 space. So every other digit would take 4 spaces within its own uh, region, and that way it stays properly aligned. And you see 100 took 3 space out of 4 spaces. So if you use the printf that way, it will align it properly. So I think we can even move this to 3. Let's see how it will print it to bring it together a little bit more. So it's taking 3 spaces, but you see the 100 takes 3 spaces. Now it's like kind of joined to 90. So 4 is pretty much a decent design. Um, all right. So do the second question is, do you guys understand how it works? Did you if I did you understand what happened here?
Yeah, I understand what happened. Where I got stuck was that the same thing you're showing now, like that space. Like I had to look it up.
Okay, great. So uh if Obi, oh yeah, I see Goswell is in the call. Goswell, good morning.
Oh, morning. Good morning, everyone.
Good morning. How you doing?
Not too good, sir.
What happened? You sick?
Yeah, yeah.
Me too. I just recovered from Corona. Did you get Corona? Should I give you some?
It's malaria typhoid.
Sorry, man. You always get that thing, man.
Uh,
That malaria and typhoid, they're
thank
not
you,
they're not afraid of you. They've been messing with you for a long time, man.
my brother.
But
The sucking demons.
yeah, good to have you around.
Yeah, thanks.
Yeah. So basically, if we try to break it down, right? So remember, we were trying to build this multiplication table, um, and we want to do it in a dynamic way. If you don't do it in a dynamic way, that means you have to start writing it one by one like that. And if you do it in a dynamic way, you can even extend it easily. So you see here that we have 10, we can easily say we want to make it 20. If we just move this to now to 20, we don't have to do anything else. And when we run it, we'll see that the multiplication table just moves all the way to 20. So that's the beauty of making it dynamic. When you make it dynamic, you don't you when you want to adjust it, it just you have to put minimum effort. So, and of course we can go to 100 or whatever number, right? So, but let's leave it at 10 for simplicity, and let's try to break down what's happening here. So, so remember we are creating in this multidimensional array, we are saying we want 10 horizontal and 10 vertical. So let me run this so we get it. So we are saying we want 10 spaces horizontal, 10 spaces um, vertical. And for every, so if you remember how array works, right? So a single dimension array, typically, if we remember how we did it, so if we wanted to write a single dimension array, we have like something like this. I will call it one dimension. Then we specify the number of uh, integers because you have to define your data type, right? So you have to tell the system you want five of it, or you want 10 of it, or you have to know how many you want to store inside it. So we know this about one dimensional array. And remember, when you now want to put in your data, how you do it now, you now say one dimension, and then you start from zero because the index position of an array starts from zero. It's equal to then you put your number. So you can say 5, you can say 45, and you just keep going to the next one until it fills in 5 of them. So remember this. So this is for one dimension array. In two dimension array, so if we made this 5 again, if we had to fill this manually by ourselves, so that means we will start going horizontally first, right? So we'll do something like this. So let's call this two dimension. So that's the variable name. So if we took this two dimension now and we wanted to fill it in, so remember this two dimension now is more of we're going to have 5 horizontal and 5 vertical. So each row will be 5 and now horizontally to be 5 as well. So if you want to fill it in manually, you now say dot, sorry, we now say 0, the first index of that dimension. So this first index now is the first horizontal row. That means if you're looking at it, we are here now. So this is, we are saying, okay, we are here, but what do you want to fill in? So we say in the first index of the first row. So this is exactly this position. Then you say, okay, we want 1 to be there. You get it. Then we'll go to the next one. So if we did a control Z, so we say on this same index 0, index 0 is the first row. We'll now say, we'll now move to the next index. So this first row, this was the first position, which was 0. Now we're going to the second position, which is 1, and we'll put 2 there. Then we'll go to the third one. We're still on this row, say 3, 2, and then we'll put 3 there, 3. And we'll do that till we get to 5, say, till we get to 4, sorry, 3, 4. So all of this now signifies that we have gotten to 1, 2, 3, 4, 5. So we can make this 4 and 5. So you see, this first row is actually this first part, and it all stays 0 because this first part is 0, the second one will be 1, the third one will be 2, the fourth one will be 3. So you have to think about it like an index, and like more like a vector. So you say the first position, the first row and the first position, the first row and the second position, the first row and the third position. So that's what we did here. And the first row is always zero because that's how the index position starts. So we filled 1 to 5. Then that means if you want to go to the second row, then it will be something like this. Then we'll go to 1. Then we start all over again. So when you say 1, 0, that means you're here. So 1, 0 means here. So you say 2. Then we go to the next one. Will still be 1, 1. So that means we're here, which is 4. And on and on and on. So if you picture this mentally, that's how you fill in this vector, this two-dimensional vector, then you start thinking of how can I make this whole process dynamic. So if you see, the first one is 0, 0, 0, 1, 0, 2, and all of that. Okay, now let's go into the code and see what we did here. So the first thing we did, we said we wanted 10 digits, right? Which is what we know. When you define an array, you have to give it, specify how much, what the size of the array will be. And this is a multi-dimensional array. So now we are going to loop through the first one. So you see, this was that first guy. So we're here. Uh, so this is the multi-dimensional array. So we looped. We are saying we're going to loop. So which is going to be looping through this guy one by one. We're going to be looping it horizontally. So the first row now is what we're in. And we said the first row start with 0. We check for the length. So this multi.length will return this number back to us. Will return 10. So it say not this 10, but to return this first 10. So so if as long as this I is less than 10, we want it to increment it. So that means we're going to start from 0, remember. So the first I is going to be 0. But since these are numbers and we know the timetable is made of numbers, we can just use the index numbers to do the multiplication one do. So now take it, let me just reduce this. So now this first loop is going to start with this. This is where it starts now. So it has created 0. Now the next thing we want to do is find this and to dynamically get the second one. This, oh, sorry. So this one we've done here, which is this for loop. Now we have to get the second one. And that's why we created another for loop inside this for loop. Because remember, we have to have 0, 0, 0, 0, 1, 0, 2, all of that. So now we created a for loop again inside the first for loop because we have to loop this side. And then we say we start with 0 as well. Because remember, the other side of the dimension also starts with 0. And it ends at 5. I mean, it ends at 4 because we count 0, 1, 2, 3, 4. And in total, it has to be 5. So then we say, okay, we're going to loop inside this first dimension. We have to create a second dimension, and that's why you have this for loop here. And then how do we do it? We say we give it a different variable name, j. We say it starts from 0, which is what you see here. It's starting from 0. And we say if j is less than this multi-I, so remember this multi-I, if you take this multi, that's the name of the array, we take the I, which is this, with the original loop it's inside, which is this guy, then we check what is the length of it. And if you do this, it will give you the length of 5. It will tell you, okay, um, the length is 5, which is what you have here. And the reason you're doing it this way is the reason you did this and did this way, this is what makes it easy for us. We can just easily extend this. Sorry, sorry. I'm pointing to this. So this would actually give you the 10 we have here. So this is just for reference. I'm using this to explain what's happening here. So this multi-length will give you this 10, and this multi-length will give you this 10. And this is important because without this, you cannot easily change these numbers. Remember, we changed this to 20 and automatically everything just recalibrated. So this is what makes it possible. This is what makes that dynamic for you because you don't have to tell it. It will just go and look by itself like, oh, how many is here? I'm going to use how many I find here to do what I need to do. So we are saying now that for the inner one, which is this one, check how many, start from zero, which is like you see in our example here. Then as long as as long as this side is less than the length, which is this length. If we're looping, it will be this one, but this is when we're looping multi, you see, we're using the same variable name multi. Then increment. So that means it should increment 0, 1, 2, 3, 4, as long as it's still less than this side of it. So now we have gotten this and this. Now the next thing is to put the value in it. So now you see we now have multi I. So remember, it loops this one first. It's on zero. So this I now will check it's zero. It will take this zero and put it here. So you see that's exactly what we had here. And then J, when it's in this loop, so it starts with zero. When it starts with zero, it came here. It now found another loop. That means it has to finish this loop first before it comes out to this outer loop. So it's still at zero. It now has zero. It now finds out that J starts with zero. It now puts zero here as well. So which is what you have here, 0, 0. Then it now checked. So since we know that um, this our for loop also has is also using numbers, we can use that numbers to dynamically create our tables. So all we just have to do is we have to say, since we have this part now, what value do we want to put here and want to make it dynamic? So we just have to check. The J now is 0. We just add 1 to it. So if we add 1 to it, we should also look at the I and also add 1 to that, because if not, it's going to be 0. So if we add 1 to it, it becomes 1. So we multiply both of them. So we say J plus 1 times I plus 1. So in this case, J is 0, I is 0, I plus 1, and J plus 1 both give you 1. So 1 times 1 is 1. So you see, it gives you this 1. And then you store it here, which is what you've just done here. Then you are still inside this loop. So until this loop is completed before it goes out. So this will loop again. I remember you said it should increment by 1. So when it increments by 1, J becomes 1. So if J becomes 1, but remember, while J is still 1, I is still 0. So it does this whole thing again and comes here. I is 0, which is exactly what you have here. And J is now 1. And this J becomes 1, which is exactly what you have here. Now, how do you get this 2? So it's the same thing. You say J, since J is 1 now, so you say 1 plus 1, because you always add it with 1. So 1 plus 1 will now be 2, and 2 times I plus 1, which was 0. Remember, I is 0, but you add 1 to it, becomes 1. So it now becomes 2 times 1 is 2. So you see, that's how you get this 2. And we keep going like that, and you see that you'll be getting 1, 2, 3, 4, 5 till 10. Then when you get to 10, that means J is now less than uh, uh, 10. This will now be false because J will be 10. It will now come out of this for loop and go back to the first one again. And then I will now be 1. So because you remember, you increment it each time. So I will now be 1. Then if I is 1, it will now come into this loop and loop all over again. So this will now be 1. This I will now be 1. And J will be 0, which is what we have here. I is 1, J is 0. Now, how do you get the value in here? It's the same thing. You now say J plus 1. J is 0 at the first one. So this will now become 1. 1 times, so I in this case now, remember, is 1 now. So 1 plus 1 is 2. So 2 times, 1 times 2 is 2, which is what you have here. Then, since you're still in this loop, it will loop this all over again. So you see, it will increment J with 1. So J is no longer 0, J becomes 1. Then this will now become 1, and this will become 1 as well, which is what we have here, 1 and 1. And then j plus 1. So j is now 1. 1 plus 1 is 2. Remember, this I is already 1. So 1 plus 1 is also 2. So that means 2 times 2 is 4. And you see, dynamically, that's how you get these numbers. So when you finish this whole loop, what you have successfully done is you have populated your two-dimensional array, but it's not visible yet. You just filled all the values in. That's what you just did in this first for loop, in this nested loop. Sorry. And when you do that, the next thing will be you want to see everything inside it, and that's what this for loop is for. This is just for printing out what is inside it. This is for filling in the values, for putting all of these numbers inside it, and this one is to show, to be able to print it out. And you do something similar, which is very similar to this, because now you want to go into each of them and get the value. So this time I named it M. It's the same idea. You increment, you go to the next one. It's just the same thing as what you have here, but I just use a different variable name, M and N. And when you do that, this time, remember, this time you only want to show what's inside it. So you don't have to increment. We're not adding anything to it. We're not assigning. We just want to print it out. So that means when you now say system.out.print, like we use printf here, put multi, the printf, like we mentioned before, the printf helps you space it out nicely. So maybe let's just get the printf out. We'll use it later just for simplicity. We'll just use the normal spacing. We'll say plus, give it a space. So we say go to this multi-dimension, go to M is 0, and N is 0. So go to the multi-dimension 0, 0, and print it out. See, that's what this is doing. System.print, go to 0, 0, and print it out. And when you print that out, it will stay in this same loop. You see, to go to this loop again, because this first loop came inside this first loop, we have another loop, and the inner loop has to finish before it will come out to the outer loop again. So that means this will go from this M will be 0, and this will be 1, and this will turn to 2. So you have 0, 1, 0, 2. I mean, sorry, you start with 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way to 10, and that will print out this first row. And when the first row is done, when it has gotten to 10, that means n is now is not less than uh, multi m dot length. It will now come out to the outer loop and print an empty space. So this empty space is just saying go to the next line. That way we get it in this next line. If not, it's going to just continue on the side. So we just want it on the next line. So that's what this print L is doing. Then it will go again, and M will now become 1, because remember we say increment by 1 as long as this stays true. So now M will now be 1. So it will now become 1, 0, 1, 1, 1, 2, 1, 3. That's printing out all those values, and that will give us all of this second row. And that's how we print out everything. Now, if we run this way without the printf, we'll see that we will get this output, but it's kind of like packed together. It's not really, you see our space here is there, but it's only one space. And when you have digits that are, um, longer, yeah, it doesn't like, it's not easy on the eye. So that's where that printf comes into play. So if we use the printf with 4D, so 4D is saying that every digit gets 4 space. So you can even make it, if we run this, first of all, you see it's well spaced out, everything stays nicely, but you can even make it 5 if you want. So if you make it 5, you see every one of them gets like spaced out 5 in, see, if you count it, 1, 2, 3, 4, 5. Every digit gets 5. 1, 2, 3, 4, 5. And that way it stays well aligned. It's kind of easy on the eye, and then you can see your times table easily. So 2 times 1, 2 times, I mean 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and on and on. So this is an interesting way to understand how this works. This is actually the solution I was looking for. It's I think it's very important to understand this. This will it might dice your brain a little bit. Remember, one thing you could do is you can put breakpoints and walk through the code. So if you put breakpoint and when you click here, you say run in debug mode. So when you do that, your breakpoint will hit and then you see what's happening. So if you go to the next line, so you see now that I is 0 and then you're in the next for loop, then you see J is 0 and then it's time to assign it, right? So you see multi ij. So when you go there, you see that multi ij now gets the value of 1 because I is 0, j is 0, and it's been assigned to 1. So to the uh, if you go to the next loop, then it becomes 2, which is what we had in our console. Okay, our console is gone. And then if you keep looping it that way, you see it keeps incrementing and j keeps going up because you're still in the inner loop and I is still 0. And that way you fill it up until it gets to 10. When it gets to 10, then it moves to the next one. So you see I is now 1. And then you do it all over again and then you start filling it in for 6, blah, blah, blah. So you can also use your debug mode to understand what's going on. I saw that if I mean, Gospel raised his hand up.
Okay, sorry. I wanted to ask how you get to that breakpoint and
So
debug mode.
debug mode
What's
just helps
the
you
importance of it?
see what your coding is doing in steps. So remember, if I just run this now, just go, it just prints this out. But what if you want to see how it's doing it? What is actually happening? Like I'm just telling you guys, look at this point, I is so I, but you can actually see that in real time in your code. And you do that by running your code in debug mode. So debug mode is just more like saying go step by step. Let me see what every step is doing. So to create a debug mode, you just come to your IDE. This is IntelliJ. IntelliJ supports debugging. So you just come to the number side, just click on it so that you click on the part where you want debug to start. You can just click on anywhere you want to look at, but for the sake of this, we can just start from here, like line 15, like we want to start from here. So when you click on it and you get this red dot, then it signifies that your debug, it's saying that when you run it, it will stop here. And then you have to start moving down by itself. Now to run the debug, you click on the play and you see you have to click on debug, not run. You have to click on debug. Debug, and this is the name of your software. So when you click on it, you see the software will come and stop here. See, nothing is happening. It just stopped here. So when it stops here, you can now see the data that it has collected so far. What are your variables? So you see these args you see here, that is this args. And it's saying that this args is empty. There's nothing inside it. And of course, you didn't put anything inside it. Then it's now here. So it's waiting for you to go to the next line. So you have to move it manually to the next line. So if you move it manually to the next line by clicking on step over, it will now show you what is inside this variable multi. So let's do that. So you see, we have now passed multi, and multi is now showing you that multi number one is empty. Look at it. We just opened it. So multi is empty. These are all those rows. And the reason you're seeing 0 is because this data type is integer, and integer is not nullable, which means that it always starts with 0. If you don't assign it anything, it will default it to 0. So this is practically our timetable in 10 dimension. We said 10 10. So if you count, this is 10 times here, 10 times horizontally. Sorry, 10 times horizontally, 10 times vertically. So it's telling you that this multi has been created and this is what's inside. So you see now this row is highlighted, which is telling, okay, this is where you are now. So what do you want to do? So it's also showing you the multi-dot length. It's also telling you that the length of this multi-dimensional array is 10. So with debugging, you can step over. So now we are in this for loop. So if I step over this for loop now to go to the next line, that means I'll land in this next for loop. Then that also means I would also see what these variables are assigned to. So let's step in. So you see now this is highlighted. Now I can see what I is. So you see I is 0, which is what I initialized it here. I is 0. Uh, multi dot length is 10. So we're already here. It's telling me already that this multi dot length is 10, which is this other 10 that we put here. So you can literally see what's happening in your code. Then we are on this line. Remember, while we're on this line, our multi I is still 0, 0, 0, 0, 0. You see? So this is where we started assigning them. So now you can now visually see that I is 0, which is what we have here. I is 0. And if I step over now, we'll now see that J is also 0. So let me step over. I'm going to use the step over button. So you now see J is 0. And that's what we did here. We said here multi, take I, so I is 0, and take J, J is 0. That means as at position 0, 0, we want you to assign this value there. So now we have not gone past this line. That's why we've not seen the assignment. But now you can already see what I and J is, and we know that. So you see, this is what's even happened. We have even seen it here. I and J is 0 because we've not assigned anything yet. So it's just telling us that we are here, and there's nothing there. It's just 0. But the moment we pass this line, that means this value on the right will be assigned to I and J. So when we step over, then you see we've passed that line. So you see I and J is now 1 because 0 0 plus 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. So we have assigned 1 to multi 0 0 point. You see, these are the points. So 1 has now been put there. So you see also visually, you see 1 has been added to this block. So if it now looped again, so we're going to the second row now. We're going to the second position, which is this one. So if we step over again, you see now J is 1. So as position 0, 1, we are saying assign the same thing. But this time, since J is 1, add 1 to J, which is 1 plus 1 will be 2. 2 times 1, which because I is 0, you see I is 0. So 0 plus 1 is 1. So 2 times 1 will be 2. That means at position 0, 1, which is this position, we're going to have a 2 there. So let's step over and you see. So you see, 2. So you're seeing it happening in real time. That way you can be like, okay, or if you make mistakes in your code, you'll be like, oh, I'm seeing that it's calculating the wrong thing. So if you keep stepping over, so you see, you can see it happening in real time. It's filling it in dynamically. See, it's gone to 4, gone to 5, gone to 6, gone to 7. Just keep looking at this. Gone to 8, gone to 9, gone to 10, and now it has filled in the first row. Now you see that this this evaluation will now be wrong because J. So at this point now, J is, let's see, J is 9, and then when we loop it, you see, it's um, so J at this point got incremented, now became 10, and 10 is not less than 10, so it now jumped out of the loop and now went to the top again. So that means we are going to be on the second row. But look now, it has filled in the first row. So if we go down again, so you see it has reset now. Now we're on the second row. So remember, if I open this multi is this guy here. If I open up multi now, you see that our first row is totally filled in. So now we're here. We're on the second row. So let's collapse it again. Let's start filling it in. So you do the same thing. It shows you where you are. I is 1, J is 0, which is on this position. If you open up multi-2, you see you are in 1 and 0 because we want to fill this in. So now we start looping again. So if you do that, you just look at what's happening here. It starts to put it because remember the math here is J is 0, 0 plus 1 is 1, I is now 1, so 1 plus 1 is 2. So 2 times 1 is 2. That's what you get here. So now j will now be incremented by 1. So if I step over, you see j is now 1. So that means this calculation will now be 1 plus 1 is 2. I is 1. 1 plus 1 is 2. 2 times 2 is 4. That means this next position will hold 4. So you see, it holds 4 now. So you keep doing that and we'll be filling in everything. So 6, 8, 10, 12, 14, 16, 18, 20. Now we're in the 10th position. Now to jump out. So you see, if we open the multi, you see our second row has been filled in. So that's what debugging helps you do. You just be seeing it happening in real time. And if the numbers here are wrong, take for example, instead of 4, you see 8 here. You'll be like, okay, something is wrong with my calculation here. Maybe I should use a different formula. Maybe I should think of a way to make it work. You understand? So that's what debugging do. And if I now press play, if I press play, I can just run everything at the same time, and then you see, then we get our printout here. And our printout happens with this line of code. So first thing we did was to fill it in. And when we finished filling in everything in, the second thing we did was to print out what we filled in. We now see, okay, the array has been filled in. Now let's print out what we have in there. Yeah, so it does take some getting used to, um, and you just have to, um, yeah, you just have to look through it for a bit. Yeah, showing, yeah, showing on the screen. You're good. Just, I'm just informing you. Yeah. So, any questions? All right. So I remember I asked you guys to look into um let me see, methods last time. I'm going to stop the training here though, because we're going to get into a much more interesting um topic, which is object-oriented programming, and I wanted you guys to look into this methods stuff. Just read through it, because object-oriented programming is kind of like something I think you have to wrap your head around. And since we don't have most of our regular students here, I would like to move it to next week because I think if you miss it, you just miss it. So it's better everyone starts together and be like, okay, so that if we start struggling, we'll be able to get it together. But please read that that parts of method if you can read up, or if you can read it up also yourself. So you see this page I I sent you guys. You see it also has OOP here, object oriented programming. Just if you can, I would really encourage you just read it all through. I'm telling you, if you read it all through, when I start explaining it, it will be way better for you. And this is the foundation of most programming languages. So I really strongly encourage you guys read it so that when I'm explaining it, even if you read it and you have questions, you ask it on that day. Be like, okay, what about this? What does this do? So read this. This is we are now gradually getting away from the ABCs. You understand? We're getting into the real stuff. This is the real. We get into the building blocks, what you really need to know and understand for you to be able to start building out softwares and stuff. And whatever you learn here, you're going to take it into different languages because almost all languages today support object-oriented programming. There are different types of programming languages, but object-oriented programming is by far the most popular. There's also something I want to show you guys, so you guys would also know because we are progressing naturally to different phases. So I just want to explain one more thing to you guys, and that is the types of programming, the types of programs we we have actually, let me find it. So up until now, you see when we write programs, we it gets printed out here on our console. This we call this a console. Sometimes you see it's labeled console, or sometimes you call it a terminal. If you also go to your computer and type CMD and push enter, you're going to get the command prompt or the console prompt. This prompt you see here is the same thing as this prompt here. The only thing is this IDE makes it easy for you. It doesn't want you to go here and start messing around. It's better just stay here and do everything at the same time. So this is a console. This is also an interface. So you see the programs we've been writing so far, when you say enter your first name, it you see it happen in your prompt, in your console prompt, or if you had to run it using this prompt, you would see it here. It will print enter your first name like you guys have been programming. So this kind of software, or when you write software that the user interacts through your prompt or through a prompt like this, that is called actually a console application. That is a console software. You see something similar here. Enter amount of sales, you enter it, the tax, it calculates the tax. This is something you guys have been doing. So if you build a software like this type of software is called a console application. Now we also have another type of software that is called a web application. So a web application is very typical like this one you guys know I own. So this is my own software.com. So this is enquete.com. It's a survey generation generating application, and you see users can log in and interact with it. So let's say I log in with this guy, and you see I have different surveys here, and I can send out my surveys. People fill it in, all of this. So this is also a software and people can interact with it. I can collect data. This is called a web application. So some people might be like, okay, what's the difference between a web application and a website, right? Well, there is a difference between a web application and a website. Typically, in face value, you might not notice a difference. But a typical website does not do anything other than just show people information. So let's see if I can find one. Uh, Let me see if this website is still on. So this is a typical website, or maybe not. It's okay. Most of the pages are just straightforward. So this website you see here was built by Ifeanyi. So Ifeanyi worked with me on this project. Um, I'm in the Ifeanyi in our group, huh? So he did a good job here. So, but why is this? Yeah, you could say, would we call this a website? So this is partially a website and partially not, and I'll explain why. So the website part of it, if you look at the home page here, everything you see here is static. It doesn't change. It's actually hard coded. You understand? This text don't change. If I want to change this text, I have to really go to the HTML code and change it. The same thing with the about page. You see, it stays the same. Everything is the same. Um, and there is, however, a page that is a bit dynamic. So this page is not a website. This page is a web application because here something you can actually do something dynamic. So I can say I can put my email. I can put the goods. And you see, the moment I chose something, you see something showed up here. If I choose something different shows up here. See, it's already behaving dynamically, depending on what I select here. So I put the telephone number. I say the weight is 60. So you see, the moment I'm typing in what the weight is giving me what it thinks the cost of this would be. See that? It's happening dynamically. So this page is a web application, because there's some dynamic stuff happening. And also, what makes it a web application as well is when we click on contact me, it actually sends this information to the owner of this website. You understand? So something dynamic is happening here. So it's looking more and more like a web application. Then we go to the tracking. So this one just takes us to a different website, and then the contact page is just a normal contact page. And we also have a back end to this. So the difference between a web application and a website is a website is static. A website has pages that things don't change. If you there's nothing you don't interact with it. But a web application is dynamic. Facebook is also a very popular one you guys know about. Uh, so everything on Facebook is dynamic. The moment you come to Facebook homepage, you everything you see here, it's so sorry. Let me not show people's pictures. Um, everything there, or if you go to Yahoo, you see this is a web application because tomorrow you come here, you're not going to see these pictures. Everything is changing. It's dynamic because someone at the back end is loading up stuff. Maybe some part of this is looking at another website to get news from it, and it's just uploading itself. Look at, you even have weather data here. It's changing. Maybe in the afternoon this whole thing changes dynamically. So when a website operates this way, it's not called a website, it's called a web application. But if this text stays the same all the time, then it's just basically a website. And mostly people build websites for their businesses because they want people to come there and get information about their product or the services they provide. So that's this one here. So we have website, we have web application. Y- These days we see more and more of web application because people want interaction, people want things dynamically to happen on their site. Then you also have what you call desktop application. So a desktop application is any software you can install on your computer is called a desktop application. So a web application, you host that on a server somewhere. A console application, you build it on it runs on your computer and only you interact with it using a prompt. But a desktop application is actually a software, and you see we already have examples here. Photoshop is an example of a desktop application because you first have to install it. You should have a beautiful Photoshop here. You install it, and then you run it, and then you use it, and you can only use it on your computer. You cannot use this Photoshop now on the web. If you want to use the one on the web, it is a different, total different type, not the same Photoshop. So this Photoshop must be installed on your computer. The same with Firefox, the same with Skype, Chrome, sorry, and VX Code. Any software you install on your computer is called a desktop application. And yes, you program it just the way we are programming stuff right now, but you program it for the computer for it to be installed. And then you have the mobile application, which you guys know about, your apps on your phone. That one can only be installed on the mobile phone. And yeah, so that's another one. And then you have embedded application. Now, embedded applications are softwares that you can install inside non-PC devices or chips, or like your TV. You see your TV uses remote, and you're wondering why is it when I press something, something happens. That's because whoever programmed it wrote the software, and that software is installed in a chip in your TV, and that is called embedded application or embedded programming. So these are the different types of softwares that you can design as a software engineer, and it's good to know the difference. So it all boils down to who are your users and what do they want to use it for. So of course, if you are designing a software for a bank, a lot of banks still use console applications like this. Or if you are designing a software that you feel like, okay, you don't want the the too much graphics, you just want people to be able to type and interact, a console application will work for you. If you're designing something that you want people to be able to see it, to appeal to people, uh, to run on the website, to run anywhere in the world. Remember, this console application will only run on your computer. But what if you wanted a software that will run anywhere, on any machine, on the mobile phone? Like people can access it through the drive browser. Then you should be talking about a web application. And then you have uh, uh, s- desktop applications. Now, desktop applications are usually large. It's something that, like Photoshop itself, is like more than 4 gig. You cannot load 4 gig on a web application because that's gonna people's data will burn up. Like Nobody's going to be uploading a 4 gig website, no. But if you want to design a high-end application that's like Photoshop, that is heavy, that can do awesome stuff, then probably you'll be looking at a desktop application. So it all depends on what are you building, what are you building it for, who are your users. That would also determine which of these applications you would choose to design. But it's always good to know what they are and what the differences are. Do you guys have any questions? So you see here, this is an example of embedded systems, embedded applications. So you see, you have like, if you go to the supermarket, you see those belts that keeps rolling. Yeah, there's a software there, and that software was built on a chip, was installed on a chip, and that controls sensors and stuff. So that's an embedded. You have the one for lights, like there's some lights that are sensitive, motion sensitive, TV, games, towers, microscope, cars, and all the stuff. Any of those things that are not computers, that are not mobile phones, that are just, yeah, devices, those are called embedded applications. The software that was built was installed in a chip, and that chip then uses that software to interact with the people. So these are the different softwares that they are. One of the most popular one, of course, is web application. I'm a web application engineer. I also design softwares, of course, standalone application. I've designed also applications you can install on the computer. Um, so I'm also quite versatile with that, but I am more of a web application engineer and architect. So as we keep working, it's good to know what you're doing and what type of applications you're building. And I do hope before we finish this course, I'm going to teach you guys how to some of the things we did here. We're going to build more of an application that you can launch and you can see. You can people can type in just not a web application though, but a desktop application because you can do that as well with Java. And I'll show you guys what it looks like. So that will look something like this. So we say Java Swing application. So let me show you how they look like. So most of them look something like this. There you go. Go to mommy. So you see, this is an example of a desktop application built in Java. This is a student management software. Take a look at this one. This one is for student registration. So you see those softwares you build where you say enter first name, enter second name, enter this. We can do those same things using a user interface like this in Java. And then when people click on register, it will take that data and it will do something with it. So this is more of a desktop application, which is this part. So you can build also that using Java. All right, that's it for today. Next week we're gonna start with object-oriented programming. Do you guys have any questions? Okay. If you have no questions, I wish you guys a lovely weekend, and we'll keep in touch. Okay. All right. Bye.
All right, thank you, sir.